Hello everyone. So today we will see the next question in the TLA Eliminator series sheet of 1300 rated problems. So the name of the problem is divide and equalize. So we have been given an array A of n positive integers. Now what we can do is we can choose a pair of elements, suppose A of I and A of j, and then we can choose a divisor of A of I and so this basically states that x should be divisor of a of I, and then we can replace a with a of I divided by x, and the other element that we took a of j with a of j into x. So we have to determine if it is possible to make all the elements in the array to be equal to a particular value. So now let's get into the problem and we'll see some examples also. So we can see that when we are dividing and multiplying with x, the product is remaining constant. So suppose it was 30 and 50. So if we multiply them, it gives us 1500. And similarly, if we multiply 10 and 150, we will still get 1500. So the most basic thing that comes to our mind is for a knife approach, if we want to make all elements equal, and we also know that the product is constant. So what we can do is we can find the product. So first of all, find the entire product and just check if this product is divisible by n. If this is divisible by n, we have a yes, else we have a no. So does this knife approach work? So the answer is no. Why does not it work? So when we see the constraints, we can see that a of I has a maximum value of 10 to the power 6 and n has a maximum value of 10 to the power 4. So what will happen is, suppose we have all n numbers as 10 to the power 6. So the product of all these numbers will become something as 10 to the power 6 to the power 10 to the power 4. This will go a lot beyond the limit of integer or even a long in C++, a long in Java, in int or long. So we cannot use that. So how can we use this logic about the products and make something out of it? So we know that the numbers are made of prime factors. Okay, so these numbers have some power of prime factors. Suppose we have a number x. X can be a multiple of prime factors in such a way that suppose it has 2 to the power y, 3 to the power z, and 5 to the power w. Suppose. And we have multiple such numbers as x. Suppose this is x1, we have x2, x3, and something like this. So what we can do is if we get all the products of these things, what we will see that we'll have some particular power of these prime factors. Okay, for everything. So suppose this is y dash, this is z dash, and this is w dash. Okay. Now what we can do is suppose we have n numbers, right? So we have to distribute. So we saw that the product is remaining constant. So we have to distribute these prime factors equally among all the n numbers. So if this condition satisfies that y dash is a factor of n and z dash is a factor of n and w dash is also a factor of n. If these conditions hold true, then only we can say that we can divide them into equal numbers. Okay, so now let's check the problem as 30, 50, 27, and a 20. So let's see what is 30 made of. So 30 will have 3 to the power 1, and then it will have 2 to the power 1 as well, and a 5 to the power 1. The next number is 50. So 50 will have 2 to the power 1 and then a 5 to the power 2. 27 will have 3 to the power 3 and a 20 will have 2 to the power 2 and a 5 to the power 1. So when we multiply all these numbers individually, so at the end, what do we have is we'll get a total number that will have 2 with a power of 1 plus 1 plus 2. So this will have a power of 4. Then we'll have 3 with a power of 1 plus 3. So it will be 3 to the power 4. And 5, that will have a power of 1, 2, and 1. So if we add, these will be 4. So we see that the powers of all the numbers are 4. And we also have n equals to 4. So we can see that 4 mod 4 for all of them will be 0. So that time we can say that yes, we can distribute them equally. So how we can distribute them? We can make all numbers as 2 into 3 into 5 if we have all powers 1, and this will give us a number of 30. So we can convert this into an array of all 30s. So we don't have to brute forcefully check what number we can convert it to, but we just have to check if it is possible or not to convert these numbers. So what is our main objective? So the our main objective becomes here to calculate the prime factors and their powers for all the numbers. So how do we do this? So now the main objective, as you saw, is to calculate the prime factors and their powers. So we will see that in the coding part directly. So giving a brief, we will directly create a map, a hash map that will contain the prime factors and their counts. The counts would be basically their powers. And then what we'll do is we will go through these powers, and suppose there are multiple powers, and for the ith power, suppose for an ith power, it is not divisible by n, not divisible by n, then we will directly say no, it is not possible to divide the numbers equally, and if nothing such happens, we will print a yes. So let's see the code. So now let's see the code. So this is the entire function that would create a map for us and give the powers of all the prime factors. So we can see that we have taken an array A, the array that will be given to us, and we will initialize a hash map. This will be empty right now, and then we will go through all the numbers. This is the basic for loop. Okay, so now what we do is we first basically remove the twos. So we'll make the number odd after this. So if a number is suppose 12, so 12 is basically 2 into 2 into 3. So what this will do is this will create 2 to the power of 2, and then we'll leave the number as 3. So after this step, we'll find all the odd prime factors that the number has. So we will start from 3 because we have already seen till 2, and we will go to the square root of the number. This is an optimized way. Instead of going till the last number, we will go till the square root of the number only. And if at any time we see that the number is divisible by that prime factor, we will simply add that prime factor and its power, and we will reduce the number by that number itself. And the last part is very essential. This is basically for cases. This is for if n is itself a prime, it's a prime number. So suppose the number is we can take it as 53. So 53 will not be divisible by either 2 or 3. And at the end, what will happen is we will find that 53 itself is a prime number. So what we'll do, we will basically add that number 53 with a power of 1 over here. So I hope that part is clear. So now the code here, we basically take the input. This is for the input, and then we create a hash map, the function that gives us. Now we will iterate through all the powers. So this is iterating through all the powers. And if at any time the ith power is not divisible by n, we will directly print a no, and we will return the from the function. And if all the powers are divisible by n, the answer should be a yes. So we can submit this code, and this will work perfectly. So let's submit this code. We'll submit this code, and this will be working fine. Thank you for watching, guys. If you have any doubts or any queries about this problem, please feel free to comment. I'll be answering your doubts soon. Thank you. So we can see that the solution has been accepted. So thank you for watching.